All right, we are covering vertical, supplementary, and complementary angles, and this is from 2.2 in your books. For those of you that want to follow along, we'll discuss 2.1 tomorrow. Okay, so your objectives, you will be able to identify different types of angles, and you will be able to determine an angle's measure based on that type of angle. Pretty straightforward stuff. Again, we're going to be involving some algebra here. All right, so let's start with vertical angles. When two lines intersect, they make vertical angles. So our vertical angles here, for example, are 75 and 75 because they are opposite one another. So where they intersect is the ones that are basically opposite. So another pair of vertical angles would be 105 and 105 because they're opposite one another. Okay, pretty straightforward. Something that you should note and is going to be very, very useful is that vertical angles are congruent always. So if you notice 30 degrees and 30 degrees, okay, congruent. 150 and 150, congruent. That is going to be a huge thing for you with your proofs, and that's going to be something that's a definition. So if angles are vertical angles, then they are congruent. So if you write it as an if-then statement, that's what you would write. However, anytime you use this in a proof, I am perfectly okay with you writing vertical angles congruent. So in a proof, you can use that for your reason, okay? So that is okay to use as a reason in a proof, okay? Now, supplementary angles add up to 180. Okay, so here's something to keep in mind. So there's supplementary angles and complementary angles. Supplementary angles add up to 180. Supplementary angles do not, I repeat, do not have to be adjacent. These two are adjacent and supplementary. These two are supplementary angles, but they are not adjacent because they add up to 180. 120 plus 60 equals 180. 40 plus 140 equals 180. I know that unless you turn your screen, it looks like a multiplication symbol. We'll do that. We'll just get rid of it. You get the idea, though. Okay? If they add up to 180, they are supplementary. Complementary angles add up to 90. Okay? So they can be adjacent and complementary like this, 30 and 60 equals 90, or they can be complementary but not adjacent, such as this, 40 and 50 equals 90. Alright, so for this example, find the value of x in the figures. So these two angles are vertical, so that tells us that we can set them equal to each other because they are vertical angles. And then it's just a matter of going through and solving for x. So subtract 2x from both sides to get this over to here. Subtract 3 from both sides to get that over to this side. You end up with 3x equals 21. Divide by 3. You got x equals 7. We found the value of x. If it asked for the angle measure, we would have one more step and you would plug in 7, which is actually a good way to check. 5 times 7 is 35 plus 8, 38. 2 times 7 is 14 plus 24, 38. It works. All right, now find the value of x in the figure. What are we going to do here? Because this is a bit tricky. Well, it's not as bad if you take what you know about vertical angles and do something like this, like extend the line down. Now, a couple of things. Remember, these mean that these lines are parallel, so something to keep in mind. Alright, so we've created a supplementary angle here by creating a line because we know that that straight line is 180 degrees, so we know that this has to be 85. Okay? With me so far. Now, something that you're going to learn a bit later on, but something to keep in mind for right now, is that because these lines are parallel, this angle and this angle are congruent. Okay? So, we know that since this is 110, this has to be 110, which again, knowing what we know about supplementary angles, means that that has to be 70. And we know a triangle is made up of 180 degrees. So if you take 180 degrees and you subtract 70, you get 110. And if you subtract 85, what do you get? You get what x is, which is 25 degrees. Okay? So the only thing that you really need to remember here, and we will emphasize this when it's necessary, is that certain things and characteristics about lines that are parallel and the lines that go through them. So that's just one way of doing it. Next, find two possible solutions for angle PQR given the diagram. So we know we have vertical angles here, so we can set them equal to each other. However, the easiest way to solve this would not be to do it like this, but to create a quadratic equation. And then we solve the quadratic equation like I know you guys can. You can use a quadratic formula, or you can factor. I threw that in there just for those of you that might actually remember it. And you would get -8 or 2, which you would then plug in to get either 4 degrees or 64 degrees. So when you solve this using factoring or whatnot, you get a -8 or a 2, and they both work. Again, angles are measures, so they have to be positive, but x doesn't have to be positive. Once you plug it in, it has to be positive. So like -6 times -8 plus 16. Well, that -6 times -8 is a positive 48 plus 16 equals 64. -8 squared is a positive 64. So that works. All right, if you used 2, -6 times 2 plus 16. That's -12 plus 16, which is 4. -2 squared, 4. Fairly simple and straightforward. So we are going to be talking about, like I said, perpendicular lines a bit. So that was 2.1 in your books, but it's really so easy, it's not even worth making a video over. So just take good notes tonight. Know your 3 different types of angles and what you can glean from them. You have a good night.